Well, hello everybody. It's Monty, it's Shadle, it's geometry, and it's Mathia time. So, when you open up Mathia and you just click on the white spot here, you'll see that we were doing slopes and perpendicular lines. The last time we were together, we started the distance formula, a little Pythagoras action. Okay, so let's continue with Pythagoras. All right, so we derived the distance formula, and the distance formula was a squared plus b squared equals c squared. And while that's warming up, we're going to actually use that to calculate distance. All right? So we got two things warming up here. And we'll remind ourselves about Pythagoras. Okay, so Pythagoras was about 2,500 years ago, and he discovered this relationship in right triangles. So we've got to have a right triangle, and when we have a right triangle, there's a relationship. So this means 90 degrees, and we'll just do a 3, 4, and then this is called the hypotenuse, the long leg. So this will be leg 1, this is going to be leg 2, and this is actually called the hypotenuse. Okay? All right. He discovered that a squared plus b squared equals c squared. In other words, 3 to the 2 power plus 4 to the 2 power is equal to the hypotenuse squared. Well, what's 3 times 3? 9. What's 4 times 4? 16. And that is equal to the third leg squared. Well, 9 plus 16 is 25. And now we have a squared. Well, we want to undo a squared. So to undo the squared, we have to take what's called the square root. Okay? And when you look here, you'll see it. Squared, square root. So if we go 25 square root, we get 5. The square root, the square root. The square root of anything squared is itself. So that's equal to the question mark. So the length of this side of the triangle is 5. And you'll see that in the practice that we do. So let's get started. All right. So we have a step-by-step here. And I love these step-by-steps because it says what's the coordinate of x1, y1. So let's scroll down here. The coordinates of E are 2, 13. So we're going to go shift 9, 2, 13, enter. And the coordinates of point 2 are 4, 12. So shift 9, 4, 12, enter. Now, we want to find the distance formula, okay? What is the distance between these 2 points? Well, think slope, okay? All we got to do is think slope, the rise over the run, okay? So let's just open up our little smartboard here. And let's do this. How do I clear the board? Clear the canvas. How do I clear the canvas? There we go. Clear the canvas. Okay, so in this case, let's just draw our triangle, okay? Boom, boom, boom. Now, do you see how we went from 12 to 13? This is only 1 unit. And we went from 2 to 4. This is 2 units. So our triangle, the rise over the run, the rise is 1. The run is 2. Okay, so now the rise, the x value was 2 units. So we're going to type in 2, enter. And the rise was 1 unit. Okay, from 12 to 13. And my face is in the way, applying you've already determined the difference between the x and y coordinates. What is the square root of the mean? So let's just click in here, and we know that 2 times 2 is 4, but I don't have to worry about that. I'm going to click here, square root, And if you're not sure, we can go 2, shift 2, big arrow, plus 1, shift 2. Whoop. No. Okay, now, there we go. Plus 1, shift 2, squared. It'll do the work for us, okay? The length of the segment is 2.232.2361, enter. Okay, so the distance formula, we're applying the distance formula. Okay, so let's go to a problem. Let's give it a try. All right, so the coordinate point here is 4, 2. So we're going to go shift 4, 2. And then we're going to go shift 8, 2. And you see how they're flat? It's a flat line, so we're just going to go from 4 to 8. It's 4 units, but we'll do the math, okay? So it's 4 units across, so 4, and it does it for us. It didn't go up and down, so that's a 0, enter. And the distance is the square root of 16, so let's just type that in. The square root of 4, shift 2. And the actual distance is 4. Does the math for us. Okay? All right. Let's try the next problem. Okay, same idea. The distance, so E, the distance of U. Okay, so it looks like a 11, 12, 13. 9, 13. I like that. 9, 13. So shift 9, 13. And this other one is going to be a 4, 1, 4, 1, 4. And now the distance, okay, the rise over the run. So the x's, 1, 2, 3, 4, 5, 6, 7, 8. 8. Yep, from 9 to 1 is 8. So let's just type that in, 9 minus 1. Cool. And 9 minus 1, 13 minus 4. It does the work for us. So now let's just put it together. Okay. So we're going to go 8, shift 6. Now I got to figure out how to get bigger print here. How am I going to do that? Okay, I could go back. What if I go back here? Let's go 9, shift 2. See, my computer, my arrow button is not working. Irritating. All right, so 8 squared plus 9 squared. Take the square root. I got a flying dragon. Wow. 12.041. All right. And again, don't feel bad. Hit the hints if you need it. Okay. Okay, so now Antonio walks to school 4 blocks west, 8 blocks north. Okay. And on the graph of the school located at the origin, determine the distance between Jamal and Antonio. Jamal and Antonio. Jamal walks 4 west, and 8 north. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so we're going to go shift -4, 8. Okay, and Antonio walks 11 east, 4 south, 11, -4. Okay, so now we have the 2 data points. So we had to read the words in order to get it. Now, from -4 to 11, let's just type that in. -4 minus 11. Because distance is a gap. It's a subtraction. 8 and -4. 8 minus a -4. 12 units. Good. Now let's just do the math. We need the square root, and we're going to go 12 shift 2, come back, didn't want to do that, and then we got a plus, and what was it, parenthesis, negative 15 shift 2, close parenthesis, whoop. Okay, 15 squared plus 12 squared, yeah, screwed that up, didn't I? 15 squared plus 12 squared. Let's see if it does it now without all those parentheses. Oh, we don't want a negative. Okay. So it didn't like my negative 15, did it? Interesting. So pay attention to that. That was kind of a strange one, wasn't it? 19.029. All right, so we're 11 minutes, 19.2094. We made a bunch of mistakes there, didn't we? Okay. All right, I don't like to make videos longer than like 12 minutes. So let's stop this video and then we'll come back and we'll finish this workspace. Monty checking out for the moment. Cool.